Hi, my name is Armando Diaz. This is a presentation for the class Computer Networks. I will be reviewing the paper Running BGP in Data Centers at Scale published by Facebook. So first of all, I'm gonna introduce BGP. So BGP is a routing protocol and is used to exchange information among routers and autonomous systems. So as we can see here on the screen, we can identify three autonomous systems. Um, let's say, for example, that a customer or a user wants to uh, make a request of a Facebook web page that is hosted on the autonomous system number three, but this user is close to the autonomous system number one. So in order to reach the web page, the request needs to go through different routers. It can be well, there are many possibilities since uh, all of these routers are interconnected, but the job of BGP is to find the best routing path, and this best routing path doesn't have to necessarily be the shortest one. It can be based on policy rules that are predefined by the developers. And well, these policy rules needs to meet some business requirements, so that's why they exist. Um, so let's just summarize what is BGP. So BGP is a routing protocol. It's designed for scalability. It can support thousands of routers and also a lot of interconnections between autonomous systems. It interconnects autonomous systems, of course. It supports large topologies, which are defined by policy rules. BGP runs over a reliable transport protocol, in this case TCP. Um, and this is very important because BGP by itself, it can do retransmission, acknowledgement, and updates. So this is how BGP works. Now, what's the motivation of Facebook of implementing their own BGP? So first of all, um, we all know that Facebook owns different applications such as Facebook, Messenger, Instagram, WhatsApp. The the user growth has been just growing exponentially, and as we can see here on the graph, just about two well 2 years ago, between 2 years ago and now, the network has been just growing 30 times, which is a lot in just very short amount of time. This requires a protocol that can be scalable, and in this case, Facebook was looking for a solution that can support that kind of growth and also number of users. So, as we can infer from this, the data center routing requirements from Facebook were as following. So the first one, they were very concerned about the scalability. That's because the quick growth of Facebook, and also they wanted the network to be reliable. Obviously, there can be some expecting failures, like for example, let's say that uh, under the maintenance process, some of the switches or racks need to be removed. So all of this hard work is gonna affect obviously the performance of the network. um, Also, they needed to be operational efficient. With this, they that means that they needed a framework or a protocol that could require the less amount of a human effort, and also that could support quick updates in case they were needed. So BGP is commonly chosen for scalability, also because there is extensive policy control. BGP, the BGP on vendor devices help grow the network very rapidly initially. But the problem with using BGP from other vendors was that when Facebook needed to make some changes due to the number of users that was increasing over time, and also just business requirements, sometimes the vendors they took a lot of time to add the updates that Facebook was requiring by the moment. So all of these reasons just push Facebook to just create their own implementations from scratch. However, obviously BGP, if you want to implement a simple, BGP protocol, it cannot be, it doesn't have to be very difficult. However, if you want a BGP that can be scalable and reliable, it can become very tricky and difficult. So what are the challenges of BGP? So BGP, um, the first challenge is long convergence. That means that, for example, let's say you have four, five, or 5,000 of routers. Obviously, if you want to make an update, like let's say, like you want to add a new router, or you want to update the policies of your BGP protocol, all of those updates sometimes take a few minutes. Few minutes can be a lot of time for a company like Facebook. Also, there are some routing instabilities um, and misconfigurations in the internet. So all of these instabilities, are problems that come from either failures and maintenance events inside the data center. Some of these misconfigurations can be triggered by bugs that are defined in the policy rules, or the bugs that just come from the BGP implementation. So Facebook solution, Facebook decided to, as I said, to design and create their own BGP routing. Um, Routing policies, they wanted to create a routing policy that could achieve reliability, and this is pretty much well the reasons and the new features that Facebook wanted to focus on. So let's look at the DC routing design with BGP. This is how the architecture looks like. Um, we have here server pods. A server pod is, as it sounds, is like a server that is composed of rack switches and fabric switches, and all of these fabric switches are interconnected with something called span plane. So an span plane switch is interconnected with all the fabric switches, and this is for to add redundancy. Also, in case, add redundancy, and also uh, if one of the let's say if the server pod 1 needs to talk with server pod N, and you have that shared memory or that shared information of uh, how all the routing paths looks like. That's just gonna be very helpful for the routing protocol to find the best routing path. So that's why we can see here a lot of interconnections and uh, information share among these servers. Um, this is one of the important things that Facebook also added to their implementation is that they wanted GVP to be reusable in terms of the autonomous system allocation. And as we can see here, they use a term called confederation autonomous system. This is just a selected is like a subgroup of routers that are inside the same autonomous system that will have um, that will be sharing the same information. So that way, if the information is reusable, they can reduce overhead when they need to make an update. So one of the most important features of a BGP is route summarization. Route summarization helps you reduce control plane processing. Why is this important? Let's say that you have 1,000 routers, and in reality, if you make if you have 1,000 routers in one autonomous system, and then you have I don't know, let's say 100 routers in a different one, if you uh, try to find all the possible routing paths, you can just imagine the number of combination of possibilities. So usually, if you don't have a route summarization, you can see that the complexity of finding the route can be O n a factorial. So in order to reduce that amount of complexity, route summarization uh, pretty much summarizes or filters the most important routing paths based on the policy rules, and also based on the shortest path, so the information can go as fast as possible. The data center policy goals that are more important for Facebook were reliability, which enforce route propagation scopes. This is predefined by backup paths for failure. I'm gonna just take a moment to talk more about it in the following slides. The other one is scalability, which enforce route summarization. We can also identify maintainability, which identifies and remediates problems that are related to the switches in the data center, and also service reachability. So obviously, we want to make sure that all the customers are able to access the applications. So reliability is predefined by backup paths. So let's say that you are uh, air RSW1. Um, no, let's say that you are a FSW1. So if you wanna reach RSW1, you can go directly from this one to this one. But also you can go from FSW1 to RS, and then FSW2, and then go to here. So we can see here we can identify quickly a short path, but also we can identify a longest path. So a backup path is pretty much a predefined a path that can be used in case link failure. So that way, the overhead or the latency of updating the new path is going to be very, very, very low. Um, so this helps with reliability. Um, as we can see here, we are just showing what will happen if this path in particular has a failure, and what would be the new path. And now in scalability, scalability is very also related to the backup path, because if you have a backup path, you can you can act quick quickly. You can act faster and find and use that path to just reroute the information over the network. This makes just the whole system more scalable at the same time. So obviously, the convergence will be very short. It will find the best path faster. Now, the operational pipeline of Facebook looks like this. So we have they try to use a operational pipeline that looks very similar to any software engineer implementation. So as we can see here, we have the testing stage and deployment stage. So the first one, it had well they have a unit testing, integration testing, system testing, and they make sure that any configuration, any update on in the policy or any update on the BGP agent needs to go through all this process. And once it's go in the deployment phase, each deployment phase is gonna deploy in different proportions over the whole application. So the testing, as we can see here, is composed of six different uh, phases. So as we can see here, the phase number six, which is defined as the global push to all switches, is the one that usually uh, has or presents more errors. And why is this? Because it's just very hard to simulate how the network will react when you deploy the when you make an update on the routing uh, protocol uh, using a very small amount of network. So let's say that the P1, which is a small number of racks switches in a random DC, this most of the time it goes through and it passes properly the test. But uh, but when you start increasing from a small number in a random place and to 10%, then 20%, and then like you go to the whole just deploy everything on the all using all the applications and all the bandwidth in all the network, and you realize that many of the deployments can present some failures. One of the important aspects of having a pipeline like this is also that you can quickly roll back. So in case there is a high percentage of failures, you can quickly go from P6 to P5, P4, or go completely back until the beginning of the the process. So in conclusion, Facebook designed BGP that was scalable, and they achieved this by reusing ASN allocation, and also by implementing the route summarization, which uh, summarized the number of routes that were allowed by the network. And also the other one is the reliable under failures. So this was achieved by predefining backup paths, and the same thing for the scalability. Obviously, the operational efficiency was achieved by using an automated pipeline that was introducing a unit testing, system testing, and also having or being able to see how the network reacts by incremental changes in the deployment. So that's it. Thank you.